Some strategies for solving systems of linear equations. In this first example, both of the equations are lines and they are in slope-intercept form. And so we will use a coordinate grid and graph the two lines and see where they intersect. That will be the solution to the system of equations. For the first line, the y-intercept is 1. The slope is -3. For the second line, the y-intercept is -7. The slope is 5, or up 5 over to the right 1. These lines intersect at 1, -2. So that is the solution to the system of equations. It's the point that satisfies both lines, or the point that lies on both lines. So for this next example, notice the top equation is written in terms of y, and the bottom equation is in standard form. Let's use substitution for this one. Let's use the expression for y and substitute that into the second equation. And so in place of y, we will put 2x plus 1. Now let's use your algebra skills and distribute the -2 to both terms in the parentheses. Combine like terms. We want to solve for x, so add 2 to both sides. And divide by -1. So that's your x value of your solution. To get the y value, we can use that top equation and now just substitute x equals 2 and do the math to get y equals 5. So your solution is 2, 5. And that was using substitution. So for our third strategy, we'll solve this system of equations by using elimination. And this is typically used when both of the lines are in standard form and the x's are above one another, the y's are above one another, and so are the numbers. And so you ask yourself which variable looks easier to eliminate. Well, if in the second equation we had 3y instead of y, do you see that the y's would cancel out? So our plan is going to be to multiply that bottom equation by 3. Notice all 3 terms of the bottom equation were multiplied by 3. Now let's add the 2 equations. Notice the y's eliminated. Let's divide both sides by 13. And let's substitute that value for x into the bottom equation. Simplify it. Subtract 3 to both sides. And you can see our solution is 1, 1. And what we used in this case was elimination to solve the system of equations.